Session 10.2 Regression. We call the session 10.1 when we have two variables, and if we want to solve if there is a linear correlation, first step, we're going to construct the scatter plot. Just like this graph here. After we construct the scatter plot, we say that if I can draw a straight line here, and all the points around this straight line means there is a linear correlation. For this session, the next step, we're gonna determine the equation of this line. And this line, we call this as the regression line. Okay, regression line. After we find out the equation of the regression line, we could predict the value of y for a given value of x. Means like, just like this picture. Let's say I want to find out when my x equal to 67, what is my y equal to? So you could look at this picture, 67, somewhere like here. So we're gonna go up, hit the regression line, and then go to the y here. That will be equal to 38. Means when x equal to 65, my y, that will be equal to 38. So this regression equation is y hat equal to b naught plus b1x. First, x called the explanatory variable or predictor variable or independent variable. So most of the time they're gonna given for the x. Y hat, this is called the response variable or dependent variable. So dependent variable because your y hat, it depends on your x. Okay, whatever the x is given, we could figure out what is my y in here. And remember, you guys learned the linear equation in the algebra class. For the linear equation, the formula is going to be y equal to b plus mx. Okay, y equal to b plus mx. That's a similar idea for this regression equation. So remember that the b naught in here, for my regression equation, the b naught, that will be equal to your b, which is going to be y-intercept. And then the b1 here, this is equal to the b plus mx, right? So your b1, this is talking about the slope. So for this line, this is increasing, right? Going on this way, increasing. So you know I do have the positive slope. So this one, the b1 should be positive. Requirements. It has to be simple random sample, and visual examination of the scatter plot shows that the points approximate a straight line pattern. So before we want to find the linear equation, you have to prove that they do have the straight line pattern. Any outliers must be removed if they are known to be errors. So this is the same requirement before you guys finding the R. And there are two methods finding the regression equation. First one, you need the formula. So this is my regression equation. You want to figure out what is your B naught. So you have the summation formula. And for the B1, you do have another summation XY formula. So use your calculator, find out your summation Y, summation X squared, plug it in. You could figure out what's your B naught and B1. Plugging back to these regression equations. So this is the first method. Second method, you're going to use the calculator. Follow the procedure of session 10.1. That will be really similar how you guys finding your R, your correlation coefficient R. A small company has 5 employees. The following table presents the number of years each has been employed and the hourly wage in dollars. Use the calculator to find the regression equation. So part A, I want you guys just use the calculator, find out the regression equation. Okay, let's try to use the calculator to find the regression equation. First, click on the stat. Number 1 added. I'm gonna plug in x on my L1, plug in my y on my L2. So I have a 0.5, enter, 1, enter. And then go to the L2, plug in the y. Okay, now I'm gonna click on the stat. Go to the test. I'm gonna go up. You're gonna find the linear regression t-test. This is the same procedure how you guys finding the R. And then enter. My x is on L1, y on L2. That's good. Okay, I'm gonna choose not equal to again. And then for the regression equation, we're gonna do vars. Click on the vars here. Go to y vars. And then choose number 1 function. And then I'm gonna choose number 1, y1 in here. And then go to calculate. Enter. So you're gonna see I have the regression equation here, y equal to a plus bx. And then they state the a and b in here. Okay, y equal to a plus bx. This is gonna be our regression equation with the a and the b in here. So plug it in, you should get this guy. Okay, 7.78 plus 1.74x. So this is how you guys find the regression equation using your calculator. And then B, construct a scatter plot with a regression equation. So since we have this screen already, we're gonna keep going to construct a scatter plot. So we're gonna click on second, y equal to, I'm gonna turn on the number 1. So enter, enter, turn it on. Okay, go down. I'm gonna choose the first picture in here. Enter. Okay, my x is gonna be on L1, y is gonna be an L2. The mark here doesn't matter which one you pick, okay? After that, you're gonna click on the zoom, okay? Zoom is gonna be on the top in the middle key here. Go to number 9, zoom step. Okay, you're gonna see your equation in here. So you do have the points, these 5 points with the regression equation. So when you guys copy this picture on your notes here. Okay, C, use the formula to find the regression equation. We already used the calculator here. Now we want to use the formula. So we have these 2 formula. So use the calculator. We already have the data on my L1 and L2, right? That's a x and y. So now we want to find the summation. We're gonna click on the stat, go to the cal, choose 2 variable statistic, enter. My x is gonna be on L1, y is gonna be on L2. Go to calculate. So you're gonna see I have a summation x squared. Okay, that'll be 19.5625 here. Summation y, you could go down. Summation y, 54.14. And then we have a summation xy also. Okay, so copy this one. You should get here. Okay, just plug it in. Use your calculator. Okay, now use the calculator to find the B naught. I'm gonna put the big parenthesis on the top, big parenthesis on the bottom. So I'm gonna do parenthesis 54.14 times 19.563 minus 8.75 times 102.148 close parenthesis. Okay, big parenthesis on the top, divided by another parenthesis 5 times 19.563 minus 8.75 square, close parenthesis. Okay, enter. You should get 7.78. It should be matched on your part A here, 7.78. Do the same thing for the B1. You already have the summation xy in here. Okay, plug it in. You should get your B1 equal to 1.74. You are not done yet. You only find the B0 and B1. Make sure write it down your regression equation. Okay, write it with like the y0 equal to B0 plus B1x. Write down your regression equation. So that'll be y hat equal to B0 plus B1x. Okay, want you guys try to do it by yourself for the number 2, and then we're gonna try to work together. So you use your calculator, you should get the regression equations like this. Y hat equal to 11.04 plus 0.82x. Your scatter plot, and then your formula. Okay, plug it in the summation x and summation y. You should get this too. Again, after you find the B0 and B1, make sure write it down with your regression equation. Okay, so the first 2 examples, we learned how to find the regression equation using the calculator or using the formula. And also we know how to construct a scatter plot with the regression equation. So now we need to know how to use this regression equation. Okay, look at this chart here, predicting y values using regression equation or the mean value of y. So first, determine the predictor variable. Which one is going to be your explanatory? Which one is going to be response variable? Okay, so most of the time when you have the chart like this, the first row here should be your x, second row should be your y. Okay, so you know here the percent provision in reading, that will be your explanatory variable. And the second one, this one, percent proficient in mathematics, that will be your response variable. Okay, and then calculate your R. We need to know if there is a linear correlation. Think about it. If we have this picture, all the points is going to be close to the straight line, we know that is a linear correlation. So it makes sense that we could use the regression equation to find the predict value of y. However, if your R is really close to 0, that means that is not linear correlation. If there's no linear correlation, you don't want to use the regression equation anymore. Okay, that will be the meaningless. So first step, find out your R. Complete a linear correlation hypothesis test. Remember the session 10.1, we learned how to perform the hypothesis testing of a linear correlation. If you have reject the null hypothesis, reject means that is a linear correlation. So you're gonna go up here. You'll be finding the regression line and then plug in your x, find the predict value of y. If after you perform the hypothesis testing, they say fail to reject. Fail to reject means there's not sufficient evidence to support the claim of linear correlation, means R may be really close to 0, that's a no linear correlation. So the regression equation is going to be useless. So what we can find the predict value of y, we'll be using the mean value of y, okay, the mean value of y. So let's try the example to figure out this one. Okay, List below are the build and tip data. Use a 0.05 significance level. I have the build dollars and the tip dollars. So the build dollars here, this is gonna be my explanatory variable. The tip dollars, that will be your response variable. A, use the calculator to find your R. So this is just like the first step here, find the R. So let's do it together. Go to the stat, go to number 1, add it. Let me clean up the data here. Okay, my L1, I'm gonna plug in my X. L2, they'll be plugging your Y here. Okay, then click on the stat, go to the test, go up, find the linear regression t-test. Enter. My X on L1, Y on L2, use the not equal to, go to calculate. So go down, I'll find my R equal to 0.828. Okay, 1, 2, 3 decimal space. This is my R. And then B, use calculator to find the regression equation. For the same screen here, we're gonna go up again. You're gonna have the Y equal to A plus BX. This is your regression equation. And then I have the A equal to negative 0.347. B will be equal to 0.1486. Okay, so plug into the regression equation. So you should get this one. Okay, A and B, just use your calculator to find the R and then the regression equation. C, what is the best predictive amount of Y hat for a dinner bill of 100? This is talking about if they given the X, if the bill dollars is going to be 100, what is my response variable of Y equal to? What is my Y hat equal to? After we find the R, we want to perform the hypothesis testing, right? So look at the calculator again. You will find your p-value, okay? Next to the t, this is the test statistic. Next to the t, that's a p-value, 0.0417. Okay, this is gonna be your p-value. So let me write it down. This is my p-value. Remember the p-value method? I'm gonna compare with your significance level. So this is gonna be less than the significance level. We're gonna reject. Okay, reject the null hypothesis. Remember the null hypothesis? That will be the rho equal to 0. Means there's a no linear correlation. Right now, we're gonna reject it. Okay, reject it means there is a linear correlation. Okay, one more time. Look at the calculator here. Find out the p-value. We'll just use the p-value method. Compare with your significance level. We know that's a reject, okay? Reject means there is a linear correlation. So go back here. When we reject it, we're gonna go up. That is sufficient evidence to support the claim of linear correlation. So now we're gonna find the regression line. We already have the regression equation. Now we're gonna calculate the best point estimate for the response variable using the regression line and the X naught. This is using the given value of X. So the given X equal to 100, we're gonna plug into the regression equation. Use the calculator. Your tip amount of the Y hat should be 14.553. Okay, it's just a 14.55. Last example, I want you guys try to find the R first, find out the regression equation. And then make sure for the part C, you want to find the p-value. and then compare with your significance level to see you're going to reject or fail to reject. Actually, when you get the R equal to 0.3412, this is close to 0. You know this is a really weak linear correlation, okay? We may have a smaller chance using the regression equation. And find the regression equation. This is going to be my regression equation. Okay, they want to find the best predict number when the x equal to 103 both, okay? So you should get your p-value equal to 0.3689. This is really big p-value, right? Compare with your significance level, so should be greater than. So fail to reject, okay? Again, no hypothesis is talking about that's a no linear correlation. Right now, you fail to reject, okay? Fail to reject. That is a no linear correlation. So what is your predict value? You don't want to use the regression equation anymore. So what is your predict value? You're gonna use the mean value of y. Remember how to find the mean value of y? You want to add it all up divided by the number of the data. Only y in here. Or I could show you guys on my calculator. So I have the data on my L1 and L2. Go to the stat, go to the test, go up linear regression t-test. Okay, calculate. So double check your word again. Your R equal to 0.3412. Regression equation 13.595 plus 0.744. Okay, then p-value. Go up. What is your p-value? 0.3689. Okay, right? So now I know that is a non-linear correlation, so we want to use the mean value of y. So what can we do? We could go to the stat again, go to the cal, click on number 2, two variable statistic, go to calculate. Remember the summation x and summation y? Actually, for the summation x and summation y, they already give you the mean value of y. That's 82.78. Okay, 82.78. So on the homework and the final, I need you guys to show me all your work like this. Don't just give me what is your predict value of y, okay? No matter you're using a regression equation or you use the mean value of y, I need you guys show me all the work like this. Show me the p-value, reject or fail to reject. Is there a linear correlation or no linear correlation? That's it for the session 10.2.